the agency, they gonna be on.
They're all on Zoom right now. Oh, great. So anyone, you can just call their name and now pop up.
Perfect.
I see.
Welcome me, and it's Friday again, seems like they come up fast.
I know.
February 2nd, and we're a little bit late getting started, but we'll get going, and so can you like to introduce yourselves?
Sure. Brian Collmore, representing the Rutland District.
Irene Renner, Chittenden North, which includes Fairfax.
Brian Campion, Bennington District.
And Richie Westman, seat 50, but senator from Memorial County, and he should be coming right along. And I'm Bobby Starr from Orleans County and represent 4 towns in Caledonia County. So this morning we have a group of people that's going to talk in regards to S-197. And we'd like to start off with Steve Dornell from the Agency of Ag. And Steve, that's a bill that we don't have control of, but we've been working with the Health and Committee in regards to S-197. And so could you give us, and I'm sure you've been in here and testified, I believe, once before in regards to that. And there's been things in the press and you know, we've been getting emails in regards to it. And so could you give us your take in regards to S-197?
Yes, sir. Thank you. Steve Dwinell, Vermont Agency Agriculture, Food and Markets. Actually, what we were hoping to do today is give an opportunity. We have recently hired, had the good fortune to be able to hire environmental toxicologist with a lot of experience in this area, Dr. Pam Breyer. And she has some information she'd like to share with you. So what I'd like to do, if it's all right with you guys, is introduce Dr. Breyer and let her talk about some of the aspects of the bill and some of the aspects of PFAS in general, since she's got a lot of information, a lot of knowledge about this area.
Sure.
Okay.
So you're gonna pass off that.
Well, I'll let the person who knows the most about it talk about it. Let's put it that way. And
Yeah.
I think everybody's better off if that happens. So Dr. Breyer recently joined us. He is
Yesterday?
Hello?
Go ahead.
Yeah, sorry. Anyway, Dr. Breyer has a PhD in environmental toxicology, and for the last 5 years has served as the pesticide toxicologist for the Maine Board of Pesticide Control. And we recently created a position within the agency for an agrochemical toxicologist, and we're fortunate that Dr. Breyer applied for the position. And so she's been hired. She's been on board, I guess, about a little over a month. And she also has an academic background with working as an assistant professor with some research responsibilities. So she's got a broad range of experience and knowledge in this area. So Dr. Breyer, you'd like to go ahead and say hello to the committee and provide the information you got.
Thank you, Steve.
Yes, good morning, Dr. Breyer, and welcome to Senate Ag Committee.
Thank you very much. I wish I could be there in person this morning to meet you guys all for real. So for the record, my name is Pamela Breyer, and I am with the Agency of Agriculture, Food and Markets. I just actually got an email. I've been here for 30 calendar days, so I definitely cannot give you the inside to what the agency's positions are or anything, but I had the position as toxicologist for the Board of Pesticide Control in Maine as Maine adopted a very similar piece of legislation. So I've been through all stages of what this bill represents. And what I would like to offer today are my reactions as a scientist going through it, and then witnessing what it looks like to administer this type of. So I have a combination. I'm going to read a little bit from your bill, and then I sent in a few slides with pictures because I think pictures really help part of this discussion. So the very first section, on section 6, is where we add a definition to the pesticide control rule and statute. And the one fully fluorinated carbon definition is just, I guess I gave up emotionally fighting this definition because I had to, right? So our state adopted that same definition. And as a scientist, it is a hard definition to work with because it waters down the meaning of PFAS. We have PFAS chemicals that we know have very clear toxic properties. But when you expand the definition to go from a group of what maybe in 2011 was about 200 chemicals to over 14,000 chemicals, you're pulling in a ton of chemicals that don't match. So when you say PFAS, you are talking about a chemical that persists. Some of these other chemicals that would be considered PFAS under this one fully fluorinated definition have very short half-lives in the environment. And I'm not saying that the fluorine magically disappears, but that the chemical decomposes in months, not over millennia. And from my perspective as a risk assessor, when I try to plot the course of a chemical as it moves through the environment, that is a really important distinction. The fact that PFOS can persist for thousands of years and it has toxicity at really low doses makes it a very important molecule to regulate. But if you have a chemical that degrades in 30 days or 200 days, the risk calculations are completely different. So that's one of the aspects. You've heard a lot of people say that it's a very broad definition and it includes many of the things that we use in our daily life. One of them that's really meaningful for me is to think about the medicines that get pulled into this definition. So defining Prozac as PFAS doesn't make any of the risk assessments that underlie Prozac any more dangerous or any less effective as a medicine. It just reclassifies it into different regulatory schemes. And it also puts folks in a difficult position. The general public, I don't think can, or I haven't seen them yet, really finally see the difference between a pesticide that's considered a PFAS and PFOS and PFOA. But there are leagues of differences. Like with pesticides, they have known half-lives, known bioaccumulation potential, and we know what the toxic effects can be of them. So conflating that it's a difficult discussion to have from when I was working as the pesticides toxicologist in Maine. But like I said, I recognize that this definition is super popular. It unifies political parties alike. And so we move on, right? Like the European chemical agencies recently adopted a very similar chemical definition. And there's two things I'd like to point out about how it was done in the EU, because I know a lot of people like to look to the EU for guidance. Is one, they were more specific with the wording of their definition. And I have one of the slides I have for you shows how if you leave the definition at one fully fluorinated carbon and don't add anything to it, it still is up to interpretation of what is and what is not a PFAS. And the other thing that the European Chemicals Agency did is they said, well, we know that they call them plant protectant chemicals, but agricultural chemicals are already regulated. We know that medicine is already regulated. We know that cosmetics are already regulated under robust regulatory schemes. And so the EU ban exempts all of those programs that are already under another regulatory authority. The EU definition is on the outside, it may not even look like an important difference, but it reads, I have it written over here. Instead of saying one fully fluorinated carbon, it says substances that contain at least one fully fluorinated methyl or methylene carbon without any hydrogen, chlorine, bromide, or iodine atoms attached to it. It's not a lot longer, but from a scientific standpoint, it's a lot more clear. In the state of Maine identified 56 active ingredients that were PFAS under the one fully fluorinated definition. Minnesota has identified 93. And that has to do with how the different regulatory agencies looked at those molecules and classified them, because I'll show you what, that's why I brought pictures today, to show you what that looks like. So when I look down to section 7, 1A, and that's where the prohibition is, that a person shall not sell, offer for sale, use, or distribute a pesticide that's been adulterated, and then it lists 6 traditional PFAS. My thoughts, just responding to that, is that as written, the Vermont statute would be less protective than what already exists in federal law. EPA has responded very clearly with their direction on how to interpret PFAS and pesticides. None of those 6 chemicals are allowed in pesticides currently. They're not. And they're also not allowed to be an adulterant in pesticides. So when Dr. Bennett will tell you the story, she has done some really important work in bringing to light an area of contamination that had occurred that was not recognized in its really important work. When that whole story broke, EPA very aggressively followed up on her research. They worked with the manufacturer. The product that she identified as having PFAS in it, by the next growing season, it was actually a mosquito, so it was a mosquito growing season, but that next season, none of that product was allowed to be used in those original containers. The manufacturer was required by EPA to pull back all of its stock and replace it, and they ended up using stainless steel containers instead of the fluorinated plastic containers for some of that.
So it was coming from the plastic then.
Yeah, in that scenario, and that seems to be the only place where we have good documented evidence of contamination of pesticides is from the containers. So what EPA has said is that any amount of PFAS in pesticide is of toxicological concern, and that it's a violation of the terms of FIFRA. And I can provide you guys the federal statute here. But essentially, once a company registers their product, from even if you're a cynic and you only want to look at this from a consumer protection standpoint, the manufacturer is never allowed to vary from what they told EPA is in that product. So any adulterant of a pesticide is really important. It's a violation of FIFRA. And within 30 days of discovery of any contaminant, but especially PFAS, the manufacturer is required to tell EPA that they found that in their formulation. And then EPA goes down the path of taking action, in which the one time that we have seen it played out with the product that Dr. Bennett found, they did that. They followed up with the company. So those 6 chemicals are not allowed in pesticide active ingredients. Excuse me. Section, I think it's A2, it goes on to say that a pesticide shall not contain a substance listed in this subsection as an active, inactive, or inert. And there's like a whole 40-minute conversation we could have just on the word inert and what that means in pesticides. But from strictly writing your bill in a way that really aligns with how pesticides are regulated at the federal level, you can have active ingredients and other ingredients. There is no such thing as an inactive ingredient. The EPA has flip-flopped on the terminology of inert and other because it's topical, but essentially it would be better if it read just active and other ingredients to make it align with federal law, I should say. It goes on to section B, where it talks about the fluorinated container. And I would like to add that high density polyethylene containers, or HDPE, are not the only type of plastic that is fluorinated. This could be expanded to include low density polyethylene and polypropylene. None of the other legislation has included that. That essentially is information that we have discovered in the course of implementing this and trying to understand container fluorination in itself. And I have a great little video if you ever want to come back for the long version of this discussion, showing what container fluorination looks like. And yesterday, Dr. Bennett mentioned a statistic, and I hate to steal this from your show, but one of the best, most reliable numbers we have for how often container fluorination happens is this 20 to 30% of all ag plastics are fluorinated. And that comes from the Ag Container Recycling Council. And fluorination is a technique that you can use on any sort of plastic that you want to make more non-porous to air. So if you have contents that you want to protect from oxygen, like oils, essential oils, and just about anything else under the sun, fluorination actually plugs some of the holes within the structure of the plastic. And I'm happy that it's not lunch, because the analogy I use here is pretty gross. So when we talk about what plastic is made out of long chain polymers. There's a carbon backbone and it's carbon, hydrogens, and carbon, 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 carbon. That's the polymer of plastic. And plastic isn't woven, and it's not all chemically bonded. Some of the components in plastic are just jammed in there together, so that, and that's, it kind of makes sense when you think about the other problems we have with plastic getting into our food, right? When we talk about bisphenol A and those ingredients that escape plastic. So you have what is like a spaghetti pile mess of long polymers jammed together, but there are still holes in it. And I like really to think about it as the clog that you get in your shower. That's why I said it's not a pretty analogy, but each hair is like a polymer of plastic. And when you get enough of them together, you can clog the movement of water through your drain, right? But then imagine the soap scum that builds up over that, and how once that gets in there, it's like impervious to water, right? And that's really what the fluorination does, is it goes in and it plugs the little holes between those polymers. And the fluorination, I was trying to see, there seems to be one chemical company that was fluorinating in a way that leads to this contamination. I can't say that that is 100% the only chemical company. There have been industry papers published showing that there are ways to fluorinate that do not produce PFAS. And this is a very topical area within industry right now. And this process has been going on for decades. I found patent disputes in the 90s based on this technology. FDA and EPA, after Dr. Bennett's story broke, both issued letters to industry reminding them of good manufacturing practices. And FDA was particularly concerned that people were using this fluorination technology on items that would go into storing food. So there are some PFAS that are allowed to be coated in containers, right? That's some of the food contact papers that we have. This is unintentionally added PFAS, definitely a contamination. It seems as though the manufacturing techniques can control how much contamination happens, but that is currently unresolved science today. At any rate, EPA considers any contamination of a pesticide to be a violation of the terms of registration and something they can take action on. One more thing about section B is it requires testing, and testing for PFAS is difficult. Testing pesticides is difficult. And when you combine testing PFAS and pesticides together, what we have seen in the last couple of years is a lot of lab results that disagree from lab to lab. And we're in the middle of just another one lab pointing to the other lab saying their results don't work. Our method is better. No, our method is better. And until we have an established method for pesticides, and it's not going to just be one method for pesticides, because what is in the pesticide product is really going to interfere with the analytical capabilities of each machine. So really what we're going to be looking at is oily, matricide pesticide, high pH, low pH. There's so many different formulations of pesticides that there will likely need to be validated methods for each of these different matrices. In section C, it says that manufacturers shall submit a confidential statement of formula and that they will submit an affidavit that says that their container was or was not fluorinated. The main rule had exactly this same bit. So the confidential statement of formula, the process of taking that information in, we went through one registration year doing both of these things while I was in Maine. It's really not as simple as it would seem. And it took a huge amount of time and money for the state to accommodate that request. I'm not, as the toxicologist, this kind of information is what I'm most interested in with pesticides, right? There's often the concept of nobody knows what's in pesticides. And it's true. It's similar to how we're never going to know the formula to coat, right? It's a protected trade secret of the companies. EPA has the complete product information, and about 10 other states also collects the confidential statement of formula for various reviews that they use for allowing the pesticides into their states. But it's not just one piece of paper. So as a maker, you may have an active ingredient that you want to use, but you don't feel like manufacturing the fragrance or the color or the surfactant or whatever the other components are. So you buy those components from other companies. And what we found is working with the people that were trying to submit the confidential statement of formula to us is that often their upstream suppliers did not want to submit their confidential statement of formula to that company so that they could pass it to us if there was concerns about the ability to maintain confidentiality. The other thing is that pesticide registrations aren't as simple as the manufacturer and the state of Vermont. There's since Vermont is smaller, it's not the biggest agricultural market, but we have just as many products registered here as Iowa. And the reason is that manufacturers, they just register every product in every state because it's easier than having an unlawful distribution event happen. So what they do is they hire companies that register for them. So what this means is the person who submits the documents to the state doesn't have access to the legal team at pick your favorite chemical company. They don't have access to the CSF, and they have arrangements where they are not allowed to see that confidential information. And so this is like one of the most boring details of one of the hardest, boringest parts of pesticide registration. But essentially the state, in order to process this, we had to create a separate portal for the manufacturer to communicate to us information that was confidential that they couldn't share with the person that was registering it. The state of Maine already has this, and I'm not trying to brag here, but it's over $1 million piece of software that registers our pesticides that doesn't exist in Vermont. And we still had to spend about $100,000 to accommodate the affidavits and CSF submissions to implement this in Maine. The affidavit submission was also difficult. The one thing that's really nice about this bill is that it makes clear that the CSF and the affidavit are both protected information that is currently in the midst of threats of lawsuits from both sides in the state of Maine. I never saw a single CSF and I never saw the answer to a single affidavit statement while I was there because of our litigation concerns from industry that was claiming their answer to the affidavit was confidential business information. So I wish I could come to you today and telling you exactly what percentage of the containers were fluorinated, but I was never privy to that information. The affidavit itself was a little problematic to implement. One, there are 12,000 products that get registered in Vermont each year. So it's like an extra thing that has to be collected from each of those vendors. The person who submits the registration doesn't have the authority to speak for the product, and they have their legal team has to talk to the manufacturer's legal team, and everybody has to come up with their own answer. And so we had initially instituted this as a checkbox on our electronic form submission. And we then had to add a little text box so that they could add a qualifier. And then we didn't have enough characters, and then we had to change it. And we had to make a bigger text box so that the answers could be longer. And essentially, the person who's registering the product wanted the ability to say, to the best of my knowledge, because they are not the person who made or distributed the product. So I think that shows the section 3 stuff. Section D just again talks about these products, the CSF and the affidavit being done during registration. That's an annual event. Again, there's 12,000 registrations approximately in Vermont each month. And it's just a high volume work. There's a lot of work associated with that. And I mentioned, I guess when it comes to the point where industry comes to testify on this bill, you'll hear from them that there has even been a paper published showing that fluorination can be done in a way that does not lead to PFAS. And the science on this is really young. There's a great website that EPA maintains. I type in pesticide, PFAS, EPA, packaging, and it will bring you to the EPA spot where they're putting their most up-to-date information as it comes down. So that's where you can go and find a list of the PFAS the EPA has found in products after testing the containers. And so this is really important. Dr. Bennett's work is a huge chasm that has to be fixed, right? There's the types of PFAS that are found from container fluorination are the exact types of PFAS that we want to have regulations on. Their PFOA has been found being created in the pesticide product because of the fluorination. So there's absolutely no argument there that this is really important. So that was through the bill. And if I might share my screen, or would you like to pull something up that says host has disabled participant screen sharing?
I did say something.
I'm sorry.
She'd like her slide.
Here.
Oh, I heard a beep.
A different
Ah.
But did you get your screen sharing?
Yes.
Okay.
There you go.
Hasn't gone full screen yet. Okay. So these are not pretty. I apologize. But part of it is just a simple communication of some of the numbers. Everybody defines PFAS differently. Currently, for the federal agency that we work with for the regulation of pesticides, the Office of Pesticide Programs, they use a 2-carbon definition. The Office of Pesticide Programs identifies 4 pesticide active ingredients as being PFAS, and they have identified 2 other ingredients that are PFAS. They have said that they're not going to take action and they're not going to differently regulate those 4 compounds just because of this classification. They believe strongly that the FIPRA vetting process has performed the risk assessments necessary. And I guess I'll say this. It's one of the things an opinion that has formed over the last couple of years is that if every chemical, like the chemicals that went into making this sweater, the dyes in it, the fibers in it, if everything here was regulated like a pesticide, we would not be in the PFAS mess that we are today, right? There simply are not pesticides that have the persistence, the toxicity, the bioaccumulation potential or the ability to move through water altogether that there are with PFAS. And the big distinction here is all these chemicals that are around us, like our pens and our computers, they're all regulated under TSCA. And TSCA has a very different standard for what is allowed and not allowed. So for a pesticide to come to be registered, there's about 15,000 animals that will be part of testing to get that product onto the market. And I could go into hours of that. So I'll move on with my table. So one of the things we hear often about inert ingredients is that nobody knows what's in them. That is true in that you will never know. You cannot, as the person walking down the street, pick up a pesticide product and see what the inerts are. That's the trade secret of the company. But EPA does. And what EPA publishes, this is the link to the website, is the list of every possible inert that's allowed in any pesticide. So there are about 5,000 products that are allowed to be used in pesticides. And you can download that link from that website and go through them. And that's how, as the toxicologist in Maine, I went through that list and I matched that list to our definition. And I came up with 3 inert ingredients that met the definition of PFAS. And I have a picture of them coming up in a bit. Maine and Minnesota share the identical definition, and it's an organic chemical containing at least 1 fully fluorinated carbon atom. I worked with my Department of Environmental Protection to kind of figure out how to interpret that. Fully fluorinated is actually not very disputed. That just means it's not bonded to hydrogen. But the A in PFAS is alkyl, and that means a carbon in a chain. And that's where the difference between the Maine definition and the Minnesota definition really kicks in. Minnesota is allowing any fluorine bonded to a carbon to be included. And I've got a picture that demonstrates this difference. But as written in this bill, I think there's further decision-making that has to happen on how to interpret it. And you can see the full nuts of EPA's definition on that webpage that I mentioned before about the PFAS packaging. When we talk about testing PFAS in pesticides, typically what is used is this method 533 or method 537.1. And this is the list of chemicals that you test for. So when the state goes out and tests biosolids, they have to pick a test method, and you only get the results for what you test for, right? So this is the example of the 29 different traditional PFAS that are tested for. These 2 methods can be used for drinking water. And so if you were to send a test off to a lab to get your water tested, this is what you would be testing for. And I tried to show some of the structures and some of the diversity. They're very heavily fluorinated compounds. Most of the time they're long straight chains, but they don't have to be. I've got a little asterisk here. EPA has gone down the path of creating a method that can be used for oily matrix pesticides. So the Anvil 1010 that Dr. Bennett will talk about is, it's a pyrethroid. Pyrethroids do not dissolve in water, so they have to be like soluble, put into something like petroleum distillates, which is really heavy and difficult to analyze through. So that's one method that's under development. But when we talk human health effects of pesticides, human health effects of PFAS, these are the structures that come to my mind. Those are why I stopped using Teflon pans 15 years ago. There's another method that just got validated this past week. I'm not as familiar with it. It's method 1633. This is the one that would be used with biosolids, tissue, and the like. I do remember in the state of Maine, and this kind of is just down a side note of testing for PFAS. We had one farm site that had spread biosolids. They had 2 different species of animal grazing, a cow and a goat. They sent milk from both animals off to be tested. One species came back very high for PFAS, and the other came back clean, but they were grazing in the same area. And it wasn't actually a difference in the animal's ability to uptake PFAS, but it was an interference in the milk. So bile acids can represent as PFOS. And essentially this method that I'm showing you here avoids the PFOS interference from bile acids. So it just goes to show it's just like we are on a path for learning how to test for PFAS, but until we get there, we're going to be looking at conflicting results over time.
Is that the farm over in Maine? That,
Yes.
yeah, and wasn't the PFAS discovered on fields where they'd spread municipal waste?
Yes. Yeah. When you run the math on pesticides adding pesticides contaminated at the highest rates seen from any of the work, no matter how valid or not, and you add it up on a farm field that may have been using that product, it doesn't hold like a candle to what you get from biosolids. Essentially, you could be using those pesticides for hundreds of years before you're going to reach the concentration of PFAS that you get from biosolid spreading.
We do that in Vermont too, right?
Wow.
We spread, we do, all the time, yeah.
No,
It is-
Municipal waste.
no, that's not accurate.
Uh,
I think there's four plots in Vermont, 4 communities that do that
so we do.
It's the,
on 4 different plots over here. It isn't, every municipality in Vermont doesn't do that.
But septic waste sources, right? Yeah, septic waste, yeah. That's one of the problems that we're finding, because when the septic waste goes down, it has PFAS in it and it goes everywhere, just like you're saying.
According to Steve, are you still on there?
Yes, sir.
Didn't you tell us that we have a minimal number of land applications, and those few are tested and retested constantly?
I'm gonna, if it's okay, I'll defer that to the Mr. Steve Cash, who is actually the one who has the most information about that.
Yeah. Well, we don't wanna interrupt Dr. Brian Breyer, so maybe he could come on after or sometime, but check that out.
Yeah, he's actually on the call, I believe, so he can, when Dr. Breyer's over, he can answer that question, I think.
Yeah.
They have licensed sites, so how many is there?
Yeah, Steve knows, actually has been really well involved in that program. I'm trying to come up to speed with
Steve Cash.
Steve Cash has those
Too many
answers.
Steves.
No pressure, Steve, but you're on deck to have the answers. I have 2 more slides, so we'll get to Steve in just a sec. This is a list of the active ingredients identified in Maine as PFAS by definition. And I included some structures on there so you could see what they are. I forgot to draw the lines on this particular slide. The one that's top, middle, that's fipronil. Fipronil is an insecticide. It's used on dog, maybe cats, I can't remember now. So it's flea and tick medicine, but it's also used in agriculture to a lesser degree. It has 2 fully fluorinated carbons on it, one on the top and one on the bottom. And so that is that's a PFAS under this definition. The top left structure, that's bifenthrin. Bifenthrin is an insecticide that's widely used for tick and mosquitoes. It has uses in agriculture also. But if you see your neighbors spraying for ticks or mosquitoes in the backyard from a company that for hire, it's that's one of the most commonly used pyrethroids for that use. And you can see on the bottom left, there's 3 little pink F's. That's the fully fluorinated carbon. The bottom left is bromethylene. This is a rodenticide. So I know you guys are looking at, sorry, I'm trying to not not be in New England here. You guys, you folks, I cannot find a replacement for you guys. I apologize. So at the bottom left of the screen, you see that there's bromethylene. Bromethylene is the go-to replacement for second generation anticoagulants. So as a homeowner, if you're looking to kill rats, you can purchase this product in big box stores. The last one at the bottom, that's Fluridone. It's an aquatic herbicide, which I know is, I threw in only the most controversial pesticides I could here. And you can see there's just one carbon with 3 fluorines. So that's what makes this a PFAS. In Minnesota, they interpreted the definition differently, and they have 93 chemicals. And I'm not really familiar. I just pulled this list off of their website, but I picked out, this is Procellacor. It's an aquatic herbicide that in Minnesota would be PFAS, but would not be PFAS in the state of Maine. And the big difference, do you see those little pink Fs, how they come off the ring structure? So essentially, under the Minnesota definition, you can have a single fluorine. This one actually happens to have 2, but it doesn't have to be. You can have a single fluorine that identifies the molecule as PFAS. And they are still working through the list of inerts. The last time I talked to Raj in Minnesota, he said that they had something in the order of teens, like around 15 inert or other ingredients that met their definition. So not a ton. These are the inert ingredients that I identified as meeting the state of Maine definition. So, like I mentioned, you go to the EPA webpage, you download this sheet of about 5,000 different compounds. The quickest way to search for these is to actually look for the letters FLU, right? Because that identifies that there's a fluorine in the chemical name. But as it's a funny list to scroll through because there's all sorts of wacky things that are put into pesticides, like putrescent egg solids, right? Garlic. You know, it's an interesting list to look through. And I stumbled on Teflon. So you see that one on the very far left. And so that's the monomer of the polymer. In order to make a Teflon pan, you would need to chemically string a bunch of these all together. But there's obviously some use for the monomer in pesticides somewhere. The one on the right-hand side is a propellant. It's actually in list 4. The National Organic Program develops lists of what can be included in organic and what cannot be. And so this is an example of a chemical. It's gaseous. It breaks down in the atmosphere after some number of days. I wanted to say 30 days, but don't quote me on that. That is not associated with any human health effects to the extent that the National Organic Program adopted it for use. I think there's one other thing I was going to say, but I can't remember it. So I'm going to stop my sharing and open myself up for any questions.
Yeah. Question for you. Irene?
Thank you, Mr. Chair. Dr. Breyer, I'm looking at your original list of definitions of PFAS, and I can't parse the difference between the Maine and Minnesota definitions. Can you help me, please?
They are identical as written to the Vermont statute. And when the statute is written like this, it leaves it up to the agency scientists to interpret it.
So would you recommend that we put in the EPA definition or another definition in ours?
I'm definitely not the person to set your policy because it will completely change how many chemicals get pulled in. If you're going to stay with the wording 1 fully fluorinated carbon, I would love to add some clarifying terminology about it being a methylene carbon and what it can be bound to. And that comes from the OEC document that kind of started the 1 fully fluorinated carbon definition. And I can provide that document. So essentially, the Organization for Economic Cooperation and Development, they wrote a paper saying, let's figure out a definition for PFAS. And they proposed this 1 fully fluorinated carbon definition. But that's kind of like the name of the definition, not the technical wording of the definition. And so that paper has some background on, and to be really clear, there's a good reason why we are having this discussion, right? Like EPA said, industry, don't use PFOA, don't use PFOS. In industry turned to very similar compounds, right? So casting this wide net, there's a very good reason for casting this really wide net with this definition, just that on the ground, it causes these differences.
Thank you. Thank you.
Could you tell us if, have you tested any of our corn or soybean treated seeds? And could you, if you have, or if you've looked at such of those two products, you know, and while you were in Maine or elsewhere, do we find the PFAS in that corn or on that corn?
I know that seed will have a coating, and that coating can be plastic, but I don't have any idea of if it would include a PFAS or not. And the places where you find PFAS are surprising. So I would leave it.
We find them everywhere, don't we?
Is it maple syrup?
Yeah.
Maple syrup.
Or in plastic jugs, yeah. But see, what we're up against is, or trying to figure out is if we should continue to use treated seeds or not treated seeds, and if we don't use treated seeds, what's the alternative seed we use in the product or the way we treat for weeds and earth, you know, germs and diseases. So, I mean, the big question is, my question is, are we finding PFAS in treated seed? Because I've been told that there is none in treated seeds, but, you know, I like to get more than one opinion.
Yeah, I agree. And I'm happy that the AIB has been looking at treated seeds. And I think just getting into, I hate using this, but getting into the weeds a bit more would shed some light there.
Is this bill about spreading pesticides with PFAS? I don't have the section, that's what the bill's about, right?
Yeah.
Okay, I don't
And,
have those sections right here.
you know, like the rodent killer stuff, that's separate.
That's totally separate, right?
And we're gonna get the licensing on that, but this is banning, it would ban treated seeds, because people are saying that they're full of PFAS. Well, are they full of PFAS or aren't they full of PFAS? It's the only question I want answered, you know, for the good of the people that we all represent. Because the opposition runs around, you know, the people that, I mean, I had 10 emails last night from people that were say, oh, we gotta ban this stuff, and I mean, they aren't probably any more knowledgeable than I am on it, you know, but they get clips from the antis, well, send this to your legislator, because they're basically saying letters.
You know, in defense of those people, my perspective on pesticides was 100% different. As a assistant professor of environmental toxicology, I had a pretty big ego. I thought I knew contaminants and have been really thunderstruck by the amount of regulation in FIFRA. There's so much misinformation that goes out about pesticides and what you can and cannot do. And a lot of it has to do with, we were all raised on DDT, and that was banned 50 years ago, right? Like it was banned 2 years after EPA was created. And so we're still working under that same, like, we still see pictures of people talking about DDT, right? Like DDT was used before we understood what the structure of DNA was. We have just come so far, and especially with regulations, after the Food Quality Protection Act of 1996, FIFRA was amended heavily in ways that people really don't represent a lot in arguments. Myself included until I was the pesticides toxicologist.
Other questions?
I don't think so.
You haven't got one? Come on.
Well, I'm wondering, Linda, can you print up those sections for us, 5 and 6? Or I just.
Oh, we got it.
No, we don't have.
We don't have 5 and 6 in front of us.
Oh,
That's,
Is that possible?
it's on your.
Right, sorry.
That's
I
okay.
just love it. Thank you.
Actually, is it 6 and 7? I think?
It's 6 and 7.
Oh, 6 and 7, okay.
5.
sure.
Dr. Breyer, we were looking, I don't know if you have the same printout we do. I'm looking at page 10, 12, line 9. It talks about section 114, and you mentioned that the PFAS and pesticides where we list 6 substances is already covered by EPA. So is there any reason for us to have a section like that in this bill?
It's not harmful
Okay.
to have it, but
Okay.
it's not adding anything. It's just a,
Is it incomplete?
the health department would have the best list of what would be considered harmful PFAS. I mean, like that judgment of where Vermont is on what we consider to be harmful PFAS, and that discussion of what PFAS we want to really be concerned about is out of my league, especially since, I've been here for 30 days.
If I could follow.
Yeah,
Thank you,
sure.
Mr. Chair. Given that the Maine and Minnesota definitions of PFAS are the same, was it just the interpretation of the states that was different? In that you have given us slides that show us vastly different numbers of?
Yep. And it from a state perspective, you don't want to be the one employee making that decision. Right? Like we're protected by unions, but that doesn't mean you don't end up in the mailroom. So
Right.
this is like, it's somebody somewhere has to be making a decision on what is in and what is out.
So
I
we should
got
make a decision in the definition ourselves by
As long
expanding.
as you make- if you make the right one, yeah.
Thank you.
That was a joke. I apologize. Having been on the other side of that, yes, that is where that's where the clarity should come from. If you guys are trying to set policy, getting that detailed information of what you want in and what you want out, and making the decision that way would be the most appropriate.
Thank you.
Other questions? Well, thank you very much, Dr. Breyer. Is very good, and appreciate your time.
Thank you. I appreciate the time.
Steve, did you have somebody that was gonna tell us about the municipal?
Yes, sir. Steve Cash is available right now. He's on the call and he has been following this issue for the agency. So Steve, you want to, do we want to restate the question or?
Well, Steve, the issue of testing of milk over in Maine on a particular farm. They had one group of cows on grass where there was never any municipal sludge spread. One eating the grass on the fields where the sludge was spread, and where the sludge was spread, of course, it showed up, contaminated with PFAS. So the question came up, well, don't we, most of our municipalities use the same process? And I thought that we only had a few municipalities that did that, but we'd like to know if you have any knowledge on that, what we're doing here in Vermont as far as spreading of sludge from municipalities.
Yeah. So first off, Steve Cash, Vermont Agency of Agriculture, Food and Markets. I do from my work with the Agency of Natural Resources on some of their sampling of land application sites, have some insight on that, but I do want to make sure the committee understands that's a program that the Agency of Natural Resources operates. And I would encourage bringing them in to answer those questions specifically. There are some sites still ongoing where biosolids and septage are spread. Those exact numbers I'm not certain on. And that's, the distinction biosolids and septage. Biosolids, we would generally come from a wastewater treatment plant. Septage is going to come from septic systems.
So you don't have any knowledge of that then?
I don't have the specific numbers. I believe they are reduced from where they were previously from my conversations with Agency of Natural Resources folks, but the specific numbers I don't have available. I could get those numbers and get back to the committee.
Right.
Yeah, would you mind just getting back to us in terms of the amount? A couple years ago, it sounded like there was a lot of spreading going on. I know that there was an amendment proposed on the floor, part of the floor, to just stop the spreading of sludge on farm fields. How many farms are using sludge, in terms of spreading? What time of year? And anything you have? I think that would be a great starter question.
All right. Yeah, that's something I can look into.
That'd be great.
And then come back to the committee. Again, I do want to say it is an A&R program in terms of the permitting side,
Sure.
but it is on farms. So, yep, happy to come back to the committee with that.
Appreciate it.
So Steve, as far as you know, there's no new permits being established to do this, correct?
I believe there may have been one last year, but again, I really would encourage you to connect with the residuals personnel at the Agency of Natural Resources on that.
Okay.
Thank you.
Thanks.
So,
Thanks.
did you have any?
No, thank you. Appreciate that.
We had you on to speak a little bit about the water quality and how you're doing in regards to contamination, things like that. So would you like to give us a little report?
I don't have anything in particular to share. I think Pam on this particular bill covered most of the territory, and I'm happy to come back to the committee and talk further on land application. But
Yeah.
nothing to share at this time.
Yeah, very good. Well, thanks for being with us, and if we have further questions, we'll get hold of you.
Sounds good. Thank you.
So do we have, is Bennett on?
Kyla.
Kyla?
Yes, I am. I am here.
Yes, good morning.
Good morning. Thank you so much for allowing me to testify this morning. My name is Dr. Kyla Bennett. I am the Science Policy Advisor for Public Employees for Environmental Responsibility, or PEER. We are a national nonprofit based outside of Washington, D.C. I am not only the Science Policy Advisor, but I also have the jurisdiction of the Northeast and New England in particular. So I am physically located in Massachusetts. I have a PhD in ecology and evolutionary biology, and I also have a law degree with a certificate in natural resources and environmental law. So as Dr. Breyer mentioned, I was the one who discovered PFAS in Anvil 1010, which led to the discovery of fluorinated containers leaching PFAS into their contents, particularly pesticides. I am also a co-author on a paper that is about to be published. There are 5 other scientists on it with me from the Center for Biological Diversity and the Environmental Working Group, and the paper is solely on PFAS in pesticides. That paper should be out soon. I will be happy to provide you with a copy once it is out.
Thank you.
Of course. I am testifying today to urge you to keep sections 6 and 7 in Senate Bill 197. It's a critically important bill. And what I want to do today is just spend a few minutes talking to you about why PFAS and pesticides is such a huge problem, not only for human health and the environment, but also for your farmers. And I'd like to address what Dr. Breyer said. I actually agree with some of the things she said and disagree with other things. As far as the definition, I would have no problem using the OECD definition. It's very similar to the one fully fluorinated carbon definition that you and other states are using or contemplating. The OECD definition is the one that we used when we wrote this paper, when we were looking at how many pesticides and how many active ingredients and inert ingredients had PFAS in them. I think the reason that states use the one fully fluorinated carbon is that it's easier to grasp and it sounds less wonky, frankly. But the OECD definition is fine. I would not go narrower than the OECD definition, and I'm going to explain why. EPA does not have a definition of PFAS. Their working definition under their Office of Pollution Prevention and Toxics is no longer used. They abandoned it. They instead are going with this very flexible definition where they're going to use a different definition depending on the circumstance. The Department of Defense does use the one fully fluorinated carbon, but EPA does not have a consistent definition. We have a universe of potentially 14,000 or more PFAS. We only have toxicity information on about 130 of those. So think about that just for a minute, because I think that's really, really critical. There are 14,000 of these chemicals. It's a huge class of chemicals. They all have one thing in common, which is that carbon-fluorine bond, which is one of the strongest bonds known in organic chemistry. It's very, very difficult to break. Many of them, but not all, bioaccumulate, and all that we have tested so far have toxicity properties. So we have, again, toxicity information on 130. I don't think it's protective of humans or the environment or our food supply to say, we don't have the evidence, so let's pretend that it's going to be okay and everything is good and they're not toxic. In other words, the absence of evidence is not the same thing as the evidence of absence. Just because we don't know yet doesn't mean that it's safe. The other thing I really want to hammer home is EPA is not protecting us. The reason that states like Vermont and Maine and Massachusetts and California and New York and Michigan and Wisconsin and all of these other states are coming up with these PFAS bills is because EPA is missing in action. Yesterday, EPA just listed, I think it was 9 PFAS as hazardous constituents under RCRA. They're about to come out with their MCLs under the Safe Drinking Water Act. But frankly, EPA has known about the toxicity of PFAS since the 1990s, and they have been kicking the can down the road forever. And I am saying that as a former EPA employee. I worked there for 10 years. In my role at PEER, I have EPA clients in the Office of Pesticides. EPA is not protecting us. I cannot say that enough. In fact, we filed a complaint with the Office of Inspector General on one pesticide known as Telone, where we alleged that EPA improperly downgraded the cancer classification for that pesticide. And the IG found that indeed we were correct. And EPA said, oh, well, and put it out anyway. If you Google or use your favorite search engine about all of these pesticides, dicamba, so many of them, we have pesticides here in the US that have been banned in China and Brazil. Okay, EPA is not taking care of us on the pesticide front, which is why we need bills like this one. So as you are aware, PFAS is this very large class of persistent human-made chemicals that lead to a number of health effects, including cancer, developmental problems in both infants and children, fertility and pregnancy problems, endocrine disruption, increased cholesterol, immune system problems, interference with liver, thyroid, and pancreatic function. PFAS toxicity also targets the immune system, which means there's a decreased antibody response to vaccines and exacerbates autoimmune disorders like asthma and ulcerative colitis, and even diabetes. Some PFAS are toxic in tiny, tiny amounts. In fact, in March of 2023, EPA stated there is, and this is a quote, there is no dose below which either PFOA or PFOS is considered safe for consumption. No dose. Accordingly, they set their maximum contaminant level goal at 0 for these compounds. No safe dose. Please keep that in mind. So PFAS gets into pesticides in one of 4 ways. The biggest contributor to PFAS in pesticide products is through the active ingredients and their degradates. When we wrote this paper that's coming out shortly, we looked at the 471 synthetic active pesticide ingredients that are currently registered in the United States of America and found that 66 of them, or 14%, are PFAS. And unfortunately, this practice of approving PFAS as active ingredients is only getting worse. When we just look at the past 10 years, that number jumped to 30% of active ingredients that were registered over the past 10 years are PFAS, using the OECD definition. There are also inert ingredients, and those are emulsifiers, solvents, propellants, things like that. Inerts are not required to be publicly disclosed on the pesticide label. And PFAS can aid in surfactancy. So in other words, when you spray a pesticide, the PFAS will let it go evenly over the leaves of the plants or whatever. So it is helpful. They also assist penetration into living organisms, which is why we found PFAS in some of those dog and cat flea things that, those stuff, the liquid that you put between their shoulder blades. It has PFAS because it helps it get into the animal. It also increases the shelf life and the stability of pesticides and sometimes reduces the foaming, which is also a positive thing. So until recently, EPA had 20 PFAS, roughly, listed as approved inert ingredients in pesticides on their list. They removed 12 of those after we harassed them for several years, but there are still 8 that are still allowed, still 8. And one of the reasons Dr. Breyer talked about how Teflon is one of them, one of the reasons Teflon is so nasty is not because of the Teflon itself, but because there are so many really bad PFAS hitchhikers in the making of the Teflon. And Dr. Graham Peasley at Notre Dame University talks about that all the time. The third place where PFAS can get into pesticides is from adjuvants. Now, these are products that are added aftermarket by the applicator themselves. Very few states pay any attention to this or regulate these adjuvants. I think California might be the only state that does, but this information is considered proprietary, so we don't know whether any of these adjuvants are fluorinated or not. And the fourth way that PFAS can get into pesticides is through contamination. Now, there are 3 types of fluorination. I'd like to correct something that Dr. Breyer said. There are 3 types of fluorination. There's something called post-mold fluorination, and that's the case that we're talking about right now, where the plastic containers are sent to this one company, Enhance. They're the only company that we know of in the world that does this post-mold fluorination. The plastic containers are already formed. They're put into a chamber. The oxygen is sucked out and their temperature is increased and they're blasted with fluorine gas. And that fluorine gas is reacting with oxygen in the plastic and whatever little amounts of oxygen are in the air. And it's creating massive amounts of PFAS in the plastic containers. EPA found concentrations in the 10 to 60 parts per billion range. Parts per billion, and remember, there's no safe dose of PFOA, and they're finding it in parts per billion. This does leach into the contents. So the other 2 types of fluorination are in-mold fluorination, and that is done while the plastic is molten and being formed. The fluorine gas is added into that hot plastic. The jury is still out as to whether that creates PFAS or not. There are some articles that say no. There are other research that says yes, but not nearly as much as the post-mold fluorination. And then the third type of fluorination is plasma fluorination, which very few people do because it's really, really expensive. So it's estimated that 20 to 30% of all hard plastic containers used in the agricultural sector, so not just for pesticides, but for fertilizers and other things as well, are fluorinated, which means all of those are leaching high levels of PFAS into the contents. There are also other sources of unintentional contamination. We're not really sure where it's coming from, but we do know it exists. So now I want to clarify some of the statements that were made both in the joint hearing last week, but also made by Dr. Breyer today. When I discovered PFAS in Anvil 1010, I didn't know it was from the fluorinated containers, but EPA did a very elegant experiment which showed that indeed it was from the fluorinated containers. And all EPA did was go after that one manufacturer, Clark Mosquito. And they forced Clark to pull all of the Anvil off the shelves that were in those plastic containers. And they did find a new container. There is a kind of plastic container. There's a company called BP Polymers that uses a kind of nylon. They don't use any fluorine, so there is no way that there's PFAS in that plastic. So there are alternatives. So it's not like you'd be putting these pesticide companies out of business. They just need to switch their containers is all, so that you don't have that contamination. But EPA only went after Clark. They did send out a letter and said, everybody tell us if you're using these containers and if you have PFAS in your products. Guess how many people responded? One company responded, and then they revoked it and said, oh, never mind, we were wrong. EPA is asking these pesticide manufacturers to monitor themselves and enforce against themselves, and they're not doing it. We know there are many, many, many pesticides out there that are using these containers. They are still on the market. They are still contaminated with massive amounts of PFAS. In December of 2023, EPA issued 2 orders under TSCA, the Toxic Substances Control Act, that ordered Enhance, the only manufacturer that does this, to stop fluorinating by February 28th, 2024. Great, the orders were fabulous. However, Enhance appealed to the Fifth Circuit which is Texas, Louisiana, and Mississippi. And you can imagine that they are not the most environmentally active court. That hearing, the oral arguments are Monday. We don't know what's going to happen, but we fully expect that the court will invalidate those orders. And so right now, containers are still being fluorinated. Pesticides are still in those contaminated, containers, contaminating those PFAS. And we don't know and won't know until later this month whether that practice is going to be allowed to continue. So having a bill like this is incredibly important because EPA may fail here, despite their good orders. I'd also like to point out that if you read EPA's orders, which were actually quite good, and we were suing on this, Pure was suing on this because EPA was doing nothing except going after Clark. They said in their orders that my town, the town of Easton, Massachusetts, we have had contaminated water for years. We just had a filtration plant built, cost us over $10 million that we have to pay for. And when we hired a consultant to find out why our water was contaminated, one of the reasons they said was because of the spraying of Anvil 1010 and the PFAS in there. So please don't tell me that this can't impact water, because it can. It really and truly can. So the bottom line is EPA is not protecting us. There is no better way to contaminate our soils, our waters, and our food supply than applying pesticides with PFAS. In 2021, 1 billion pounds of pesticide active ingredients were applied to farmland throughout the country. 1 billion pounds. Pesticides are some of the most widely distributed environmental pollutants across the US. They do not need PFAS in them. We have over 10,000 pesticides available to us. There are many that don't have PFAS in them. We do not need to add PFAS to the mix. And because PFAS are so persistent, each subsequent application adds more PFAS into our environment. And this is evidenced by two pesticides, both with PFAS active ingredients, fipronil, which I believe was one of the ones that Dr. Breyer mentioned, and bifenthrin. Those were approved in 1996 and 1985, respectively. They are the most widely detected pesticides in U.S. streams, lakes, and rivers, and they are found at levels that exceed aquatic safety threshold. Why are they persistent? Because of the PFAS. Another example, in beeswax samples taken from commercial beehives in multiple U.S. states in 2007 and 2008, 98% of these beeswax samples contained the 1980s era PFAS pesticide fluvalinate. PFAS are forever. They are forever. We have to protect farmland and farmers from these chemicals. Pure has cases all over the country, Maine, Michigan, Texas. In fact, last night I stayed up late on the phone with another lawyer and my Texas clients, two farmers. They were sobbing. They are losing their farms. Yes, it's from biosolids, but as these regulations get tighter and tighter on PFAS in drinking water, in soil, and in groundwater, it behooves you to not be spreading more through PFAS, not only to protect your streams and your rivers and your drinking water and all the people of Vermont, but to protect your farmers. My heart was breaking for these farmers last night. They were sobbing. This was their livelihood, their family farm for hundreds of years. And they didn't even spread the biosolids. It was a neighboring farm that spread them. Up in Maine, Songbird Farm, Adam, he didn't spread the biosolids. They were spread in the 1990s. And he had to move off because whenever there was a drought, the PFAS in the soil, they were inhaling it. It was that dangerous. They had to vacate the property. We do not want to add PFAS willingly to our soils, our foods, or our waters. And then finally, one note about testing. As Dr. Breyer said, testing for PFAS is difficult. We've kind of got that handled now. Testing for PFAS and pesticides, particularly the oily matrices, it is indeed very difficult. And that is why you're seeing conflicting results appearing depending on what analytical methodology is used and where the testing was conducted. And it confirms the difficulty of testing complex mixtures like pesticides for PFAS. However, and while I'm not allowed to say much more, I'm not at liberty right now to say much more, I want you to know that Pure is challenging EPA's memo that disputes the findings of large quantities of PFOS in some pesticides. We are going to be asking for a retraction of that memo, and we believe it is false. We did some FOIAs, we got some information, and they are just wrong. So the bottom line is there are a lot of PFAS in a lot of pesticides. We don't know how it all gets there, but we do know it's there. It's a huge problem. EPA knows it. EPA is not protecting us, and that's why this bill is so critical for you. So in conclusion, the long-term impacts of using mixtures of extremely persistent chemicals on farmland in Vermont every year is a cause for concern. Most, not all PFAS and pesticide products or their degradates are going to be legacy pollutants, and their ultimate impact on human and environmental health are largely unknown. As Rachel Carson famously said, if we are living so intimately with chemicals, eating and drinking them, taking them into the very marrow of our bones, we had better know something about their power. And here we do know the power and the danger of PFAS. I urge you to please keep Section 6 and 7 in Senate Bill 197 to protect Vermont farmers, to protect your food supply, to protect your water supply. And again, I'm fine with changing that definition to be consistent with OECD's. In fact, I think that's not a bad idea that Dr. Breyer had, but I would not go more narrow than that. Thank you so much. I'm happy to answer any questions.
Yeah, well, thank you for being with us. How do we know if there's PFAS in the treated seeds that we buy here in Vermont? Are there some companies that have agreed not to use plastic containers and PFAS that we could head see, we have mostly dairy farmers, not grain farmers, and they use this for animal feed, but we want to keep our animals healthy and certainly the farmers healthy and not contaminate our lands. So how do you tell?
You can't tell. And actually, your question about the coated seeds is a really excellent question. We've been asking that ourselves. To my knowledge, nobody has tested those seeds for PFAS. Somebody should. We've been talking about it. It's just expensive. It costs thousands of dollars to test. And we're a small nonprofit. I'm actually, frankly, tired of doing EPA's job for them by finding all this PFAS in these products that we're finding. But somebody should test. And if Vermont has the money to test, you should, to use an independent lab and figure out if it's in there. As far as who's using those plastic containers that are fluorinated, the only one we know that is not is Clark Mosquito. They're the only ones. That information is proprietary. It's confidential business information. Neither EPA nor Enhance will tell us who is using their containers. So we have no idea. And just so you know, it's not just agricultural products. It's in household cleaning products and auto supplies and personal care products like shampoos and food. So it spans, and fuels, it spans a number of sectors, not just agricultural products.
Well, you talk about plastic containers. Some of our maple sugar producers are using plastic containers to store their sap in while, they're waiting to get the boiler to boil maple syrup down. Sounds to me like we've got a lot bigger problem, on many products, as we think about this. I know my son-in-law or grandson-in-law, he found out about the PFAS in plastic. So he went and bought a stainless steel tank to take the place of the plastic one to avoid that. But you see thousands of those, maybe 500-gallon plastic tubs with a metal cage around them up here doing hundreds of different things. And
yeah, it's very scary. I agree, Senator. And I only buy maple syrup now that comes in glass jars. I never really thought about the fact that they could be in plastic, fluorinated plastic, before they get into the glass jars. But we will know soon. Like I said, oral arguments on that case are Monday. If EPA's orders stand, then by the end of this month, Enhance will have to stop fluorinating. Now, obviously, there are still those containers on the market, and they will gradually, though, go away. But if EPA's orders do not stand, then that is a huge problem, not just in the agricultural sector, but agricultural sector is a huge problem. Also, here's the other problem with those fluorinated plastics, and it's mostly HDPE. It's true that some of the other plastics can be fluorinated, but Enhance only fluorinates HDPE, which is the number 2 recycling symbol. So when those things are recycled, because as you probably are aware, those hard plastics, the ARC requires that they be recycled. They're triple washed, which means all that PFAS is coming out in the wash. And there's still PFAS in those containers. They're recycled and it's contaminated the recycling stream. And we have evidence of that. We've tested the recycling stream. And then they're taking that recycled plastic and making irrigation pipes out of them. So we're watering our farm fields with PFAS contaminated plastic. So we really need to shut down this fluorination. And we're hoping that the Fifth Circuit does the right thing. I'm not confident they will, and I don't know if the Department of Justice will appeal. If they don't, we just have no idea what's going to happen.
Yeah. Other questions? Brian?
Thanks. It was really helpful. I appreciate it. My community in Bennington, southern part of the state dealt with PFAS, continues to deal with PFAS. We identified the source of the PFAS, but it's interesting now in Vermont, we're seeing it really across the state. We have a school, Craftsbury, in your district.
Yeah.
I'm wondering, I mean, this is a very rural community, and I'm wondering if the source of that, now kids are drinking out of plastic bottles, which isn't great either, in order to, so they don't drink the PFAS. But I don't know if they've identified the source, but it's possible it's agriculture.
Yeah, biosolids, as Dr. Breyer said, is a huge, huge problem. It is indeed a worse problem than PFAS and pesticides. Which isn't a minute. The PFAS and pesticides is awful, but biosolids are a huge, huge problem. Pure is working on that problem. We are going to be filing a lawsuit shortly, but what I'm seeing in Texas is, it's horrifying. The levels of PFAS that we're seeing in these fish and these cows and the well water, and these aren't even farms that put the biosolids down themselves. It's a huge, huge problem. Now, EPA has been contemplating for several years, they regulate biosolids, they regulate 9 metals. You cannot land apply biosolids if they have over a certain level of 9 different metals. They have been thinking about regulating PFOA and PFOS, just 2 PFAS out of 14,000 in biosolids for years now, but they have yet to make a decision. And it's a huge problem because we can't destroy the PFAS. And so what do these municipalities or septage companies, wastewater treatment plants do with all of that stuff? I mean, there aren't many options. You can incinerate it, but often a lot of that PFAS will volatilize and go through the air and then drop down and contaminate someone else. You can landfill it and then it gets in the landfill leachate. And, so it's like this cycle of PFAS. So ultimately, the long-term solution is to get PFAS, all non-essential uses of PFAS, out of products. I mean, we don't need it in our mascara and our guitar strings and our carpets and our couches. Are there some essential uses? Maybe, but I could probably count those on the fingers of one hand. And they are in some medicines like Prozac and Flonase and Paxlovid. Paxlovid has PFAS, but there's so much in so many consumer products that it has contaminated our biosolids. And indeed, the amount of PFAS in the influent going into the wastewater treatment plant is less than the amount of PFAS coming out. So in other words, not only are the wastewater treatment plants not treating or removing the PFAS, they're actually creating more. We see we see the same thing happening in some whole house filters for water filtration. So it's a real big problem.
Good. Come to think about it, I live out in the country and I have a water filter between the well and pump, or the well and holding tank. And there's a big plastic thing that holds the filter up in place. It's not glass. I don't know about that. Maybe that's what's wrong with me, is that water's contaminated.
Well,
People tell me there's something wrong with me, and that may be just a
there's a list of filters that NSF has, and they are certified to remove PFAS. I have one at the point of entry in my kitchen sink, and I use that water for cooking and making ice and coffee and feeding it to my dogs. And that is definitely not fluorinated because we can test the water coming out of it. So not all plastic is fluorinated,
Oh, good.
So it's about, enhanced fluorinate's about 200 million containers annually. And again, across all sectors, it's unlikely that your water filter would be fluorinated because the reason they fluorinate those things, it's usually for aggressive chemicals like pesticides or flavorings or things that smell like those citrus cleaners and things like that. Something that's got really strong scent or flavors or aggressive chemicals like household cleaners, things like that. Shampoos with the scent. But for something like a water filter, it's unlikely they'd have to fluorinate it because there's nothing to keep in.
Yeah, yeah. Other questions? Well, there are no other questions, but we certainly want to thank you for the presentation and I guess waking us up to the fact that we'd better get on to this and so you don't really know if treated corn seed and we'd have to test that product that the corn seed is treated with, right?
Yeah, if you have, I mean, actually, if you guys want to test it, we have an account with a lab, a good Eurofins, a good independent lab that can do that testing. If you have some seed, we can test it, but it's just a little expensive. It would cost probably, actually, it would probably cost about $1,000 maybe to just test some seeds.
Well, and how many seeds would you need?
Less than about a quarter of a cup.
Well, I guess it would be well worth the $1,000 to have that done.
Yeah, I agree. I agree. It would be very interesting.
Could you email us the information on that, or should we send it to you, or how?
I'm happy to email the information to you, however you want. I'm happy to do that. I can also let you know what happens. I'm going to be listening in on the oral arguments down in Louisiana on Monday for the enhanced case, and I can let you know what happens with that as well. But I'm happy to email you my contact at the lab and have them get back to you on that. They can get you an estimate.
That, because when we grow animal feed corn, and then we grow quite a few increasingly every year soybeans, and they aren't always used for animal feed, but a lot of it's used for animal feed. And I'd hate to have our milk truck tested and find PFAS in the milk, because we'd end up like the guy did in Maine and the people you were chatting about from Texas.
Yeah, it's very, very sad. It's really heartbreaking to talk to these farmers. And Vermont has a PFAS problem in your soil. A lot of it may be from ski wax. They don't really know why. There's one article out that everybody uses about background contamination in soil, and it's done in Vermont. And you've got some pretty high levels, and no one really knows why. One of the reasons may be the ski wax, but that's a whole nother can of worms.
Next Friday, if you had the time, we have a half hour or so on Friday that we could get you back on in regards to this, what you find out Monday.
I am around on Friday. I'm happy to talk to you. I don't know if we may not have a court decision on Monday. It's going to be the oral arguments. I don't know how long the appeals court will take. It's a three judges, so they're going to have to write an opinion. We will not know by next Friday. We will have an idea of how it went just from listening to the judges and the questions they're asking, but we won't have a final decision for probably several months.
Well, maybe if you're going to be around, you could give us your opinion on how it went. And,
Sure.
I don't wanna take a lot of your time, but, our open time is around 10:45 Friday morning.
I am around and I'm happy to fill you in.
Linda, you'd be able to confirm that?
Yes.
Yeah, well, if there are no further questions, thank you very much, very enlightening.
Thank you so much for allowing me to speak.
Yeah.
Thank you, Beck.
Do you folks wanna take a break?
Sure.
We have
Two more, yeah.
two more witnesses.
Right.
So